See, I told you Newton's third law. When for Newton's third law, what is Newton's third law now? What did you understand?
So when two objects are interacting, then the force a body applies on the other body, then there is an equal and opposite force the other body applies on the first body.
Excellent. Understood now? So the two bodies must interact with each other. That means this body must interact with that body must interact with that. Condition number 1. Then, if the first body applies force on the second body, then the second body will apply equal and opposite force to the first body. Mathematically, Fa bar is equal to minus F bar. This is the condition. And yesterday I was telling you some example. So what you should do? You should take an elemental current, IDL. I hope you understand elemental current. I have already told you. Small piece of wire. How small? Very small. Not equal to 0. Right? Now I have taught you Biot-Savart's law. So what is there around this? There is magnetic field. So there is magnetic field everywhere due to this conductor, except where? There is magnetic field due to this conductor, this current everywhere except along this line. You understand? There is magnetic field everywhere except along this line. Now similarly consider another conductor. Okay, this I1 dl bar, this is I2 dl. Understand? So for this also, there is magnetic field everywhere except along this line. Understood? So now understand here. Due to this magnet, now understand here. Due to this magnet, this current, the magnetic field due to this is present here. Agreed? Because it is like this. So this will get affected. Agreed? But the magnetic field due to this at this point is 0. So this will not get affected. Understood? So this is applying force on this. So this object is applying force on this object. But this object will not apply force on that object. So Newton's third law fails here. Understood? Understood all of you? So therefore Newton's third law is not universal. See, we say universal law of gravitation. We don't say universal Newton's law, because there are few exceptions for this. Is it clear to all of you? So you have to understand these terms, universal and others. Now quickly tell me what is Newton's first law. Quickly, come on, tell. Unbalanced force is needed to change the state of motion of a body. Very good. Otherwise, the state of motion will not change. Sweet answer. See, it is a very loaded answer. You understood the word loaded? Right? I hope you understood the word loaded. See, he has used very, very strong concepts. He has used the concept of unbalanced force. And he said the state of motion. The state of motion remains unchanged if there is no force acting. No force means no net force acting on the body. Newton's second law.
The velocity of a body changes if and only if force acts on the body. External force acts.
That is first law. So you don't know. Here you tell.
The body will preserve the state of motion.
Hey Dana, ninga adaka by heart madi ninu upegilla. First law na by heart madi. You again here you have told first law. First law will tell you that force is necessary for a body to change its state of motion. Or in other words, there is a property called inertia which is responsible to preserve the state of motion of a body. And the external force has to overcome the inertia of the body. Understand? Inertia resists change of motion. This is first law. Understood now? See, I am using strong words. This is what I say, you have to elevate yourself from high school to college. Newton's second law, you see, if you see all the physics, the first law will usually define some things qualitatively. The second law is meant to measure the effect. So if the net force is not, see, first law says if the net force is 0, then there is no change in motion. Second law says if the net force is non-zero, then what happens?
The force is proportional to the change in velocity.
Yes. So in other words, if the net force on a body is not 0, then it results in acceleration. It results in acceleration. I suppose you understood this. So second law will measure the force. So second law is going to tell you if the net force is not 0, then it will result in acceleration, and this acceleration is directly proportional to the force acting and inversely proportional to the inertial mass. In other words, the Newton's second law will say there is acceleration produced at the instant the net force is applied to the body, and this is proportional to the net force acting on the body and inversely proportional to the inertial mass. Is it clear? Huh? Hello? Hello?
Yes, sir.
Now combine these two. Yesterday I given you this equation. Combine these two. I will write it as a bar of t. Now see here, I am not writing a bar. I am writing a bar of t. Means what?
Acceleration and time t.
Time t. This is instantaneous. This is equal to, okay, some constant k, the instantaneous force at that moment divided by the mass. I am combining the two effects, the two outcomes of two separate experiments. Is it clear? Okay. Now here you see, or I can write this as F bar is equal to some other constant k dash m a bar t. I hope you understood constant k, constant of proportionality. You understood or not? Hey, Dana, yes or no anak bartidilla. So it is this. Now here Newton played a very important role. He said, look, what you have to do. You take a body of mass m. You take a body of mass m on a smooth surface. What you have to do? You should take a body of mass m on a smooth surface. On a smooth surface. You take a body of mass m on a smooth surface, right? And then you apply force. You apply force. Okay, at that instant, supposing this was smooth, if you apply force such that this body, if you have taken this body of mass 1 kg and if you apply some force F, and at that instant its acceleration is 1 meter per second square, then the force that this finger applied is 1 Newton. Okay, so Newton explained this. So in this case, you see, if you take mass of 1 kg and if it produces acceleration of 1 meter per second square, then I will claim that I have applied a force of 1 Newton. So 1 is equal to k into 1 into 1. That means k is equal to 1. So if you have chosen all the quantities in SI system or CGS system or whatever system of units, then the value of k becomes 1. Then if you are going to use this equation with all the quantities in SI system, then you can write this equation as F bar is equal to m into u bar. When the equation is written like that, you must know that this is written for instant of time t. That is, F bar of t is equal to m into a bar of t. Understood? If it is not written, you should interpret it like this. These are instantaneous values. This is Newton's second law. Right? So what is Newton's second law?
Acceleration.
No, ಅವನ ಒಬ್ಬನ ಕೈ ಎತ್ತದ ನಾವು 9th ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಅವ ನೀವು ಹೋಗಿರಿ ಆಲ್ರೆಡಿ IIT ಕಾಲೇಜ್ಗೆ ನೀವು ಹೇಳ್ಬೇಕಿದ್ರೆ ಅಟ್ಲೀಸ್ಟ್ ನಾ ಈಗ ಕಲ್ಸಿದ ಮೇಲೆ ಹೇಳ್ಬೇಕ ಹಾವು ಹೊಡೆದಿರ್ತೈತೆ ಕೂಡಬಾರ್ದಂಗ ಹೇಳ.
The acceleration is proportional. The acceleration and time t is proportional to the force and inversely proportional to the inertial mass.
And inversely proportional to the inertia. Got it now? Combined mathematically you can write it like this. That's what you have got to explain. Understood? Then third law I have just explained to you in the morning. So these three laws govern the motion. These three laws govern the motion of bodies which are not very small and which are moving with velocities very much less than the speed of light. Understand? That means the motion is always obeying these three laws. Is that clear to all of you? You will understand more of this as we keep using them in a different, as we keep learning ahead. Right? Learning ahead means now we are going to now learn more concepts. To learn more concepts, we will be using all these concepts and laws. So our attempt is to build the theory of motions. Now we are just learning one by one, stage by stage we are learning this. Okay?
But this is a quantitative definition. Qualitative definition of single
See, good question. See, as far as second law is concerned, it is quantitative only. Qualitatively, if you want to recognize it, I can just say that the second law is meant to measure the force. See, till this point, what is 1 Newton? See, I slap you or you push something. How much force are you applying? Some force, but you have to measure it, no? See, you can measure what is the mass of this because you have a standard mass. I will give you a standard mass 1 kg. With respect to this, you will compare this. See, if you have kept a jaggery of this much thickness on a scale, and if you keep 1 kg 5 units on this side of the balance, right? Then what happens? You are going to get, then you will say 5 units of 1 kg. That is 5 kilos. But 5 Newton force, what will you keep? How will you measure? So Newton gave us an idea how to measure the force. How did we measure the force? By seeing the effect of force. You caused acceleration of you caused acceleration. You can measure acceleration because you can measure velocity. You can measure change of velocity and you can measure the time. Acceleration is rate of change of velocity. You can measure it. And also you can measure the mass with the physical balance. Right? And using these two measurements, you are able to measure the force. Newton told how to measure the force because he related the acceleration and the inertial mass to the force by the experimentation. Right? So the second law is meant to, is going to tell you, it is going to help us to, it is going to help us to measure the force. That is the qualitative definition. And quantitatively, how you get it? It is like this. And third law is again a standalone law. It says the origin. See, it is now telling that look, a body cannot apply force on itself. A body cannot apply force on itself. There must be another body applying force on the first body. And if they interact, this is what is going to happen. That I have explained to you. Okay? Right. Shall we proceed?
Yes, sir.